Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. Today we have this very special package. In this class we're going to be looking at decimal powers and bases. Of course, in some indices you have where the base is in decimals or where the power is in decimals. So we want to quickly look at a case where either the base is in decimal or the power in decimal or both in decimals. Now guys, listen carefully. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos, and don't forget to share this video and follow us up as we teach you in this video. Do not skip any part of this video and ensure that you avoid every unnecessary distractions and pay maximum attention. Let's get to work. Now on the board we are asked to simplify the following. Now, one of the things you must understand about decimal powers or decimal base is that anytime you are given decimal powers or decimal base, you must first convert those decimals to fraction. Then you solve with the fraction. Finally, you can leave your answer in decimals, accepted, or leave your answer in fraction. But you do not solve with what? Decimals. You must first convert the decimals to fraction. Now, somebody may ask, how do you convert decimals to fractions? That is simple for us to handle. All right, so we are quickly going to handle that very shortly. I'll be explaining the best way you will understand. All right, it is easy, very easy to convert decimals to fractions. All you just need to know is to know the number of decimal places that are there. You know, we have 1 decimal place, 2 decimal places, 3 decimal places, 4 decimal places, and so on and so forth. So let's get to work. Now we have question 1 to question number 4. So question number 1, we have 0.008 all raised to the power of 1/3. Now, of course, based on this question, leaving out the decimals, we know that this obeys rule number 5, where you have a fraction such that the numerator is 1, but the base, the denominator, is any value greater than 1. Are we there? Yes. The numerator is 1. So this obeys rule number 6. But before we can apply this rule number 6, we must ensure that we remove this decimal. This is all about decimals. So we first of all convert this to what? A whole number in terms of fraction. And how do we have that done? Just follow me up as we convert this. Just check inside this number. In these numbers here, we have 0.008. What is the actual number here? The actual number here is 8. Hope you can see it here. The actual things are 0. Ignore zeros. The actual number here is 8. So you put down 8. Put down the division now. So how many decimal places is this number? 3. Decimal places is that. After the decimal point, how many numbers do you have? This is 1, 2, 3. Is that correct? That means you have 3 zeros. So this decimal point you have here, put it down as 1. Then after the decimal point, how many numbers do you have? Or to how many decimal place is this value? To 3 decimal place, then you have 3 zeros added to this one. Decimal point turns 1. Then after decimal point, the number of values you have after decimal point returns to the number of zeros that you have. Then this will have given us 1/3 as the power. And now that we have successfully removed this or convert this from its decimal points to what? Its fractional form, all we just need to do now is to now apply rule number 6. Now, rule number 6, this will have given us the cube root of 8/1000. And don't forget, 1000, the cube root of this would have given us what? 2 multiplied by 2 multiplied by 2. All over. Why for this guy? It would have given us what? 10 multiplied by 10 multiplied by another 10. Hence, we will pick one of the values at the numerator and as well pick one of the values at the denominator. Now, we will not be able to leave our answer this way because 2 and 10 have something in common. What can divide 2 and can also divide 10 is 2. So 2 into itself is 1 and 2 into 10 is 5. This is the answer to this question. Like I said earlier, you can decide to also leave your answer in decimals if you choose to, or most especially for those who are writing objective. All right. So if your exam is an objective examination and You check your option, you do not have fraction in your option, but decimals there, you need to convert this to its equivalent decimals, and that would have given us 0.2. Alright? Okay, so we are not here to convert fraction to decimals, but our interest here now is to convert decimals to fractions. So in another video, we teach you how to convert fractions to decimals without the use of calculator. Are you there? Now, number figure 2, we are given 0.25 all raised to the power of what? Minus 2. Now don't forget that this is negative power involved here. This is the base, but we have a negative power. So first of all, let's quickly implement the negative power. Or before we even implement the negative power, we can convert the base to its fraction form. Are we there? And this base now is in decimal. To convert to its fraction form, all you just need to do is to check what was the actual value there? 25. Pull down 25 all over this decimal point. Take it to be 1. After the decimal point, how many values do you have? 2. That means this value is to 2 decimal places. Then you add 2 zeros to this one. 25 over 100 is what will give us 0.25. You can check this out with the help of your calculator. Are you there? Alright, so this will have given us 25 over 100 all raised to the power of minus. It's as simple as this. So the next thing we are quickly going to do is to now implement rule number 4 by removing the negative sign and changing it to the reciprocal of the base. And the base here is 25 over what? 100. So this will have given us 1 all over 25 over 100 all squared. So at this point, all we just need to do is you can divide out this value that we have here. Of course, so 25 can go into itself to give us 1, and 25 can go into 100 to give us what? So all we just need to do now is to have this as 1 all over 1 over 4 all squared. 25 into itself is 1, 25 into 100 is 4. Now we can square this. This will have given us 1 over 1 square is 1 and 4 square is 16. Now we have multiple fractions here and we cannot leave our answer like this. So what do? We simply have this one, then turn this long division to this division, 1 over 16. This over 1. Then finally, what do? We will change this division to multiplication, and we are going to have 1 multiplied by 16 over 1 using the law of inversion. Are we there? Now 16 times 1 is 16, and 1 times 1 is 1, and anything divided by 1 is the same. So this is the answer to this very question we just had on the board. Now, another way to quickly solve this question without wasting time is this. Now, when we converted to this, we had 25 over what? 100. Please follow me up. Another way to also solve this question without all of these long processes, in 2 steps, you will get the answer. All you just need to do, 25 into itself is 1 over 4. Are you there? Then raised to power minus 2. Now 1 over 4 is exactly the same thing as 4 raised to power minus 1 multiplied by raised to power minus 2. And understand that in indices, the fifth law of indices, which is called the product rule, says that power outside the bracket can multiply the power inside the bracket. So minus 1 times minus 2 would have given us plus 2. Is that correct? Minus 1 times minus 2 will give us what? Positive 2. And 4 multiplied by 4 will give us 16. Or 4 squared is 16. So this is another short way to have this done. But we just decided to go through this process. But when you are looking at CBT, always go for the best way, the shortest way, so that you can meet up with time. Alright, so this is another way to have this done without using this reciprocal aspect. So 25 into 7 is 1, 25 into 100 is 4, all raised to power minus 2. Now 1 over 4 is the same thing as 4 raised to power minus 1. So that power multiplies power, you have positive 2. And 4 raised to power 2 is 16. Hope this is clear. Yes, now we have the power to be what? In decimals, which is 0.2. And before we will solve this, we need to convert that decimal to what? A fraction. And to convert 0.2 to a fraction, all we need to do, put down the number there, which is 2. Is that correct? Yes. Now the decimal point, change it to be 1. After the decimal point, how many values you have is 1. That means this question is to 1. This value is to 1 decimal place. So you put 1, 0. That's all. Now something is common between 2 and 10, which is what? 1 over 5. Is that correct? So this will have given us 1 over 5. Just ensure that the fraction, you work it out somewhere. Are you there? Yes, that's it. Now the next thing we quickly do is, this is sixth law of indices. All I need to do now is to have the fifth law, the fifth root of 32. And the fifth root of 32 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by another 2. 2 multiplies itself 5 times. 2 multiplies itself 5 times will give us 32. So all we just need to do is to pick one of the values, and that becomes our answer. That's all about that. That's all. Then finally we have Roman figure 4 on the board. Okay? So we have Roman figure 4, 0.027. All raised to the power of 2 over 3. So first is to convert the decimal to fraction. So to convert the decimal to fraction, this is 0.027. So the actual number that we have here is 27. All over this decimal, turn it to be 1. After the decimal point, how many values do you have to the right? 3. So you have 3 0. Or to how many decimal place is this figure? To 3 decimal place. That means you have 3 zeros. That is to say, this would have given us 27 over 1000, all raised to the power of 2 over 3. Now that we have successfully converted this decimal to fraction, then we can solve it. Of course, we have solved something like this before now, right? Yes. So what do? All we just simply do now is to implement law 7. This is law number 7, when you have numerator and denominator as the power of the base. And the denominator is more than 2, the numerator is more than 1. So let's go. This would have given us, we put the denominator here, the denominator of the power to be the root of the base, and this is the base, all squared, which is the numerator. As simple as it. Okay? So this is 1000. Now, the cube root of 27 is 3 times 3 times 3. And the cube root of 1000 is 10 times 10 times 10. All squared. So what do? Now that I have been able to get a particular number that will multiply itself 3 times to give me 27, and also obtain a particular number that will multiply itself 3 times to give me 1000, then I will pick the number. So I pick 3 from here and pick 10 from here. I am done with the root and this 3. Then I put down 2 here. So finally, this is same as 3 multiplied by 3 over 10 multiplied by 10. Finally, this will have given us what? 9 over 100, a fraction 4. Then if you need this in decimals, you can also convert to decimal, which will have given us 0.09. Right? We explained earlier, we are not dealing with conversion of fraction to decimals. We are only dealing with decimals to fractions. So in another video, like I promised, we are going to explain how to convert from fraction to decimals. Alright now guys, if you find this video helpful, please don't forget to share this video and ensure that you like this video. Comment when necessary, and don't also forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for exciting videos. Follow us on all our social medias to get other content that will not be released here on the YouTube channel. Bless you, thanks for watching. We love you guys. See you in the next class.